All right, guys. So we are going to practice some more density problems today just to get really good at it, because next time we are going to actually do a density lab. So I got this worksheet just off of, I just Googled density problems worksheet. So we're just going to work through this. This is not in your notes. So you probably will want to get a scratch piece of paper out or something like that to help you work through these. I can attach the PDF of this to the Canvas page as well. So I'll do that. Let me make a note of that so that I remember to attach the PDF to the Canvas page so that you will actually have this as well. So you could follow along with that as well. So once again, because we're doing unit conversions using density, we are going to want a calculator. So grab yourself a calculator, make sure that you've got a pen or a pencil and some scratch paper, or if you have that PDF, you can print it out and follow along. So here we go, density practice problems. So a block of aluminum occupies a volume of 15 mils and weighs 40 grams. What is the density? So the thing that we have to remember here is that density is mass divided by volume. So we're going to just plug in this formula right here. Density is mass divided by volume. So if we think of this, mass is always in the metric system done in some kind of grams, whether it's milligrams or kilograms or whatever. So we have our mass of 40.5 grams. And volume is always in some form of a liter. And here we're using milliliters. So we're going to have 15.0 milliliters. Now, there are two main units of density that we use in chemistry, if you haven't already noticed. We will usually put things in grams per mil, or we will use grams per centimeter cubed. Now, if you remember correctly, milliliter is a centimeter cubed. So essentially, they are the same unit. One helps us really worry about fluids, i.e. gases or liquids. And then the centimeters cubed really is what we can use really well for solids. So that's the main distinguisher between those two units. So let's do the math here. So we're going to take 40.5 divided by 15. So if I do that, 40.5 divided by 15, I get an answer. My calculator spits out 2.7. Now, I should have a problem with this, because if we look at significant figures, our first number here has 3 and our second number has 3. So that means we should also be reporting 3. So what that really says to me is not just 2.7, it tells me 2.70 grams per mil. And if you look up the density for aluminum on Wikipedia or any chemistry page, you will find that aluminum has a density of 2.70 grams per mil. Okay, so let's look at this. Mercury metal is poured into a graduated cylinder that holds exactly 22.5 mils. The mercury used to fill that cylinder weighs 306 grams. From this information, calculate the density. Once again, we are going to use the same formula. Density is mass divided by volume, okay? So once again, mass is always given to us in some form of grams. So we're going to put that on top, 306.0 grams. And volume is usually given in some form of liters. Here we have milliliters. So we're going to have 22.5 milliliters, okay? So let's plug that into our handy calculators. 306 divided by 22.5. This will give us 13.6 grams per milliliter. Now let's look at our sig figs. Here I've got 4 and here I've got 3. So I can report 3, and I've reported 3 so far. So that is all looking good. And I've got my units here. Now remember, in Canvas, don't put your units because Canvas only will really accept numbers. But when we write it out, I really would like you to put units down. Okay, so let's go on to number 3. What is the weight of ethyl alcohol that fills exactly a 200 ml container? The density of ethyl alcohol is 0.789 grams per ml. So this is where we're actually going to have to use our unit analysis to get at it, because we're not going to just be able to put a mass or a volume. I'm given a volume, but I'm not given a mass. So I'm going to use the density that I'm given to create a value for a mass. Okay, so here we are going to use our unit analysis. I'm going to start with the 200 mils of the ethyl alcohol that I have. And I can't write. I just wrote a 3 instead of a 2. 200 milliliters of ethyl alcohol. And I want my milliliters to cancel. So when I look at this density, I'm going to put the milliliters on the bottom, which it already is. I have 0.789 grams in 1 milliliter. So that allows me to cancel out my units of milliliter and just be left with units of grams, which is exactly what I want. So I'm going to take 200 and I am going to multiply it by 0.789. And I will get, my calculator will spit out 157.8 grams. Now let's look at sig figs here. Here on the 200, I have 4 digits. And on the 0.789, I have 3. So that means I can really only report 3 digits. So let's look at this number. I've got 1, 2, 3 digits. So that means I'm going to use that 8 to inform me to round up. So that means when I'm all said and done, I really am going to round that 7 to an 8. So this is going to be rounded to 158 grams of ethyl alcohol. Okay? Any questions on that? We can work on that some more later. Okay, number 4. A rectangular block of copper weighs in at 1,896 grams. The dimensions of the block are 8.4 centimeters by 5.5 centimeters by 4.6 centimeters. From this data, what is the density? Okay, so the very first thing I need to do is I need to calculate my volume. So isn't volume length times width times height? So I'm going to use these values right here as length, width, and height. So I'm going to take 8.4 centimeters. I'm going to multiply it by 5.5 centimeters and then multiply by 4.6 centimeters. Okay, so when I do that, let's see, 8.4 multiplied by 5.5 multiplied by 4.6. My calculator gives me 212.52 centimeters. Okay, now the thing is, I'm not so sure that I want to round quite yet because I'm not quite done. I want to find the density, and this is just giving me the volume. So I'm not quite done. So I'm going to keep all of these numbers until I'm absolutely done. Because if I round right now, I would have to round to 2 digits, which would give me a volume of 210. So let's look and see what it does if it really changes things, if we get a rounding error. So density is 1896 grams. I'm going to divide by the 212.52, and I'm going to compare it with if I rounded. And let's do a comparison and see the difference there. So here I'm going to divide by, I'm going to take the 1896 and I'm going to divide by what I have. Let's see. And that will give me 8 point, let's see, really, this will give me 8.92. Let's see if I round it. This will give me 9.208. So if I round to 2 digits here, I would call this 8.9 grams per centimeter cubed on the copper. And if I did this to 2 digits, I would call this 9.0 grams per centimeter cubed on the copper. Okay, so notice that when we round early or in between things, it does kind of change our answer a little bit with rounding errors. So I would suggest that we don't round until the very end. Make sure that you keep as much of the data as possible until the very end, okay? And then do your rounding. All right, let's look at number 5. A flask that weighs 34.5 grams is filled with 225 mils of carbon tetrachloride. The weight of the flask and the carbon tetrachloride is found to be 703.55 grams. From this information, calculate the density of the carbon tetrachloride. Okay, so we have to do a little bit more math on this one because we have the mass of the flask or the graduated cylinder, and then the mass of the cylinder with the carbon tetrachloride in it. So if I have this mass, with the carbon tetrachloride in it, and this mass without the carbon tetrachloride in it, what can I say about the difference between those two masses? Wouldn't I say that the difference in those masses is the mass of the carbon tetrachloride? So let's find the difference between those two masses. So I'm going to take the mass with the carbon tetrachloride, which is 703.55 grams, and I'm going to subtract or take the difference of just the mass of the flask. Okay, so when I do this, like 5 minus 0 is 5, 5 minus 8, ooh, I have to carry, don't I? So 15 minus 8 is 7. 2 minus 5, I'm going to have to carry again. So 12 minus 5 is 7, 9 minus 4 is 5, and 6 minus 3 is 3. So I should get, let me make sure I did my math right. So 703.55 minus 345.8. Yep, 357.75 grams. Now, you should see that I made a mistake in there in terms of significant figures. Now, if we look at this, this goes to the 100th, and this only goes to the 10th. So in reality, I should only be reporting this to the 10th. But once again, I'm not completely done with my answer. So I want to hold the amount of information that I can until I'm completely done with my answer. We can once again see if this changes, though, our answer. So we have, we say that we filled this flask up to 225 mils. So we can take our mass divided by the volume and get our density. I'm going to change color here. So we have a mass of 357.75, and we have a volume of 225 mils. And this will give us, let's divide that out. This will give us a density of 1.59 grams per mil. Now let's see if I rounded this in the interim, that would actually be 357.8. So let's see if that changes it. I don't think it will. Yep, we still get 1.59. Now, if we look at the sig figs for this part, this top number really has 4 because we really shouldn't be reporting this digit. And this number has 3. So we can report 3, and we've reported 3. Okay? All right, let's do our next one. We want to calculate the density of sulfuric acid, and we have 35.4 mils of sulfuric acid weighing in at 65.14 grams. So once again, density is mass divided by volume. So we've got a mass of 65.14 grams, and we've got a volume of 35.4 mils. Okay, so when we do that, 65.14 minus, or not minus, let's do a divide, 35.4. Our calculator gives us 1.840112994. Now, we can't really use all those digits, so let's figure out where we want to round. So we've got 4 digits there that are significant. We've got 3 here, so we're going to use 3. 1, 2, 3. That 0 tells me to just leave it. So I'm going to report this as 1.84 grams per milliliter for the sulfuric acid. Okay. Next one, here we go. Find the mass of 250 mils of benzene. The density of benzene is 0.8765 grams per mil. So once again, we are going to use our unit analysis to figure out how we get to a mass. I'm going to start out with our volume of benzene. So I've got 250 milliliters of benzene, which is C6H6. Okay, I want my milliliters to cancel, so I'm going to put milliliters from my density on the bottom. So in 1 milliliter of benzene, I've got 0.8765 grams of benzene. Okay, so my milliliters will cancel and I'm left with grams, which is exactly what I wanted. So I'm going to take 250 and I'm going to multiply it by the density, which is 0.8765. And I will get 219.125 grams of benzene. Now, I can't use all of those digits, so let's look at our sig figs. Here I've got 4, and here I've got 4 as well. So 1, 2, 3, 4. That 2 tells me to round down. So 219.1 grams of benzene is what I have. Okay. Hopefully this is starting to make a lot of sense. All right, a block of lead has dimensions of 4.5, 5.2, and 6 centimeters. The block weighs in at 1,587 grams. From this information, calculate the density of lead. Okay, very first thing we've got to do is calculate the volume of this block. Now we are given the dimensions of each of those sides. So if we remember, the volume is always length times width times height. So we're going to take the 4.5 centimeters. We're going to multiply it by the 5.20 centimeters. And we're going to multiply it by the 6 centimeters. So here we go. 4.5 times 5.2 times 6. We get 140.4 centimeters cubed. Now, in all reality, we have 3 sig figs here, we have 3 sig figs here, and 3 sig figs here. Here I'm using 4. I really should round to 140.0, but once again, I'm not done. I want to find I want to calculate the density. So I'm going to just keep it here for now. All right, density is mass divided by volume. So let's take the mass. The mass is given to us, 1587 grams, and our volume, 140.4 centimeters cubed. Okay, we can try it both ways. And we're going to have a decimal point there to show that that 0 is significant, because it is. Okay, let's see if we do have rounding error. 1587 divided by 140.4. This gives us 11.303, and 1,587 divided by 140. This gives us 11.335. Okay, so let's look at this. If I really look at the amount of sig figs I have, this really is 3 and this is 4. So that means I should round to 3 digits. So 1, 2, 3, that 0 tells me to leave it. So 11.3 grams per centimeter cubed. 1, 2, 3, that 3 tells me to leave it as well. So 11.3 grams per centimeter cubed. So in this case, rounding in the intermediary steps didn't change our final answer. All right, number 9. We've got 28.5 grams of iron shot. We're adding it to a graduated cylinder containing 45.5 mils of water. The water level rises to the 49.1 mil mark. From this information, calculate the density of iron. So this is what we are going to be doing in our lab. So what we're going to be doing is we're going to have that graduated cylinder. It's going to be filled to some water. We're going to introduce some odd-shaped things in there, like some metal shot, or maybe, I don't know, some marbles or something like that. And that is going to cause that level of the water to rise when we introduce that foreign objects. So we have our initial reading of our water and we have our final reading of our water. And this difference here is the volume of the foreign or the shot or the whatever objects we put in here. So what we have to really do is we've got to find the difference between the two levels of water to give us the volume of the object. And then once we've got that volume, then we can start constructing how to get the density. So I have my final volume, which was 49.10 mils. And I have my initial volume without the metal shot of 45.50 mils. And I need to find the difference of that. Okay? So if I do that, let's see, 0, 6, that will give me 3.60 mils. And yes, that 0 is significant. Notice our measurements go to the hundredths. So this measurement also needs to go to the hundredths. So that is our volume. And density is mass divided by volume. So if I look here, I've got a mass of 28.5 grams. I'm going to divide it by my volume, 3.60 mils. So here we go, 28.5 divided by 3.6. This gives me 7.916 repeating. So let's look at our sig figs here. So if I look at my significant figures, I've got 3 significant figures here and 3 here. So that means I can use 3. 1, 2, 3, that 6 tells me to round up. So I am going to report this as 7.92 grams per milliliter for that iron shot as a density. Okay, any questions so far? Hopefully this is making sense. If you do have questions, please email me or come into Flex. Okay, so this is our last example. What volume of silver metal will weigh exactly 2,500 grams? So we have a density of 10.5 grams per centimeter cubed. So let's see, let's start with our mass. I've got 2,500 grams of silver. And I don't want my grams, I want a volume. So that means I'm going to put my grams of my density on the bottom so that I can cancel out my grams here. So I'm going to put 10.5 grams of silver will give me 1 centimeter cubed of silver. That way my grams of silver cancels out and I get centimeters cubed, or a volume of silver. So I'm going to take 2,500 and I'm going to divide it by 10.5. And my calculator gives me 238.095238.1. Now there's no way I can use all of those digits. So let's look at significant figures. Here, I didn't write that very well. That should have a 0.0. So I have 1, 2, 3, 4, 5. I've got 5 digits that are significant here. In this density, I have 1, 2, 3 digits that are significant. So really, I can only use 3 digits. So 1, 2, 3, that 0 tells me to leave it alone. So I am going to report this as 238 centimeters cubed, because centimeters cubed of silver is what I have. Okay, any questions or concerns, please come and contact me. Come during Flex. And next time we will have a lab and you guys will actually be doing these kind of things. Have a great day. Talk to you later. Bye.